Today's lesson is formulas of ionic compounds. So for today's lesson, you will need a periodic table, your periodic table of ions, and the polyatomic ion chart. So our topic is formulas and nomenclature, often abbreviated as FNN. So we know what a chemical formula is, and nomenclature, this just means the name of the compound. So for example, if we have table salt, our formula is NaCl, and the nomenclature or the name is sodium chloride. So remember that when we have a monatomic anion, the name ends in IDE. Okay, so for today, we're going to concentrate on compounds whose first element is to the left of the staircase. So we're going to look at compounds whose first element is to the left of the staircase. And of course, we mean the staircase on the periodic table. Now, we are going to include hydrogen. Hydrogen is often an exception, but not in this case. We are including hydrogen, even though the elements to the left of the staircase are mostly metals. A few metalloids there, mostly metals, and hydrogen is a non-metal. We are including it here. Now, hydrogen is a very special element, and when it is in compounds, hydrogen can either have a positive charge or a negative charge. Hydrogen has one proton and one electron when it's neutral. Hydrogen can lose that one electron and become H plus the hydrogen ion, a cation, or hydrogen can gain one electron and then have two valence electrons, just like helium, the noble gas that is next to it. In that case, our hydrogen gains an electron and becomes H minus, and this is called the hydride ion. So let's add hydrogen to our periodic table of ions. Okay, so over here, we're going to put in our H plus and H minus. So when hydrogen is at the beginning of the compound, it'll be H plus. When it's at the end of a compound, that's when it would be H minus, acting as the anion. All right, so we are also, in the naming we're doing today, we're going to include, L-U-D-E, we're going to include compounds containing the ammonium ion, which is NH4. That ion has a positive charge. So if our compound begins with NH4, even though nitrogen is to the right of the staircase, if the nitrogen is followed by 4 hydrogens, then we are going to include naming that compound with compounds whose first element is to the left. And that is because these elements, these are usually ionic compounds. And ammonium is an ion, and it forms ionic compounds. The system that we're going to use for formulas and nomenclature of these compounds is called the stock system. There are other systems, but we're only going to learn one system. All right, so today we're going to go from the name to the formula. Name to formula. And we're going to write down a list of steps on one side, and then we will do an example on the other side so we can see what happens step by step. And the example we are going to use is lead, Roman numeral 4, sulfate. Okay, so that's the name of our compound. We want to write the formula of that compound. So step 1, we're going to write the cation symbol, then the anion symbol. Cations always come first. Okay, so lead, Roman numeral 4. So lead we know is Pb. This Roman numeral tells us the charge of this particular lead ion. If we look on the chart we made yesterday, we see that lead can be 2 plus or 4 plus. In this compound, it is 4 plus. That's what that Roman numeral tells us, the charge of that ion in the compound. Now we have to write our anion symbol, sulfate. The fact that it ends in ATE is a clue that this is a polyatomic ion. So I go to my polyatomic ion chart and look for sulfate. Now just start at the top, and there it is, sulfate. And we're going to write it just like this, SO4 in parentheses with a -2. Actually, you could put 2 minus or -2. That doesn't matter which way you do it. Okay, so SO4, 2 minus. We're done with our first step. Step number 2, we're going to cross the absolute value of the charges down. So we're going to cross the absolute value of the charges. And we are going to cross to the outside of any parentheses. Okay, so we're going to take this 4, we're going to bring it down to the outside of the parentheses. We're going to take this 2 and we're going to bring it down to the lead. So that is step 2. Step 3, we're going to reduce the crossed numbers to lowest whole number ratio. Reduce the crossed numbers to lowest whole number ratio. All right, so we have 2 and 4. We do not consider anything inside the parentheses. These atoms are covalently bonded together. They stay together as a group. So we are only looking at the 2 and the 4. So we can divide both of these by 2. So we get 1 to 2. Our lowest whole number ratio is 1 to 2. So our last step is to rewrite it with element symbols and subscripts only. Going off the paper there. Rewrite with element symbols and subscripts only. So this means no charges in our final formula. Okay, so to rewrite it, we have PB. And you can put the 1 there, but you usually do not see it. If there's no number subscript, it's understood that there is 1. Our SO4 must stay in parentheses. And then outside of the parentheses, we put a 2. So that is our final answer. That is the formula for lead Roman numeral 4 sulfate. So notice that this 4 that's after the lead in the name is not the subscript in the formula. The 4 is used as the charge, and that gets crossed. So this is the formula unit. It represents the formula unit for the compound. And what this formula is telling us is that we have 1 Pb, 4 plus ion, and 2 SO4, 2 minus, SO4, 2 minus. This is what we have in our formula unit. 1 lead ion with a 4 plus charge, 2 sulfate polyatomic ions, each with a 2 minus charge. Okay, so let's do a bunch of examples. Okay, so we'll do an easy one. Let's look at magnesium, chloride. Now, in the last chapter on bonding, we would have done the electron dot structure for each of these atoms and then shown the electron transfer, add atoms when we needed to, and that will certainly give us the right answer. But the steps that I've just given you are a little shortcut and much easier and faster when you are writing formulas. Okay, so we're going to follow our steps. The first step, we're going to write the formulas for each ion. So magnesium is Mg. We look on our periodic table of ions. Magnesium is in group 2. It loses 2 valence electrons. Magnesium has a 2 plus charge. Chloride, this is monatomic chlorine as an ion. It is in group 17, and we can see from our chart that it is F minus. All right, step 2, we're going to cross the absolute value of the charges. So we bring the 2 down, and then we bring the 1 down. That minus means -1. Then we check our subscripts. 1 to 2 is the lowest whole number ratio. So now we go ahead and write the answer with just the symbols and the subscripts. So we have Mg. We don't have to write the 1, and you usually will not see a 1. F2. And that's it. That is our answer. So this means that in our formula unit, we have 1 magnesium ion and 2 fluoride ions. All right, let's try another one. This one will do zinc, phosphate. Okay, so we look for zinc on our periodic table of ions, and zinc is part of the slide. Zinc, even though it is in the D block, it is a type 1 element. Zinc only forms 2 plus ions in compounds. We don't see a Roman numeral there. It's not necessary because zinc is always a 2 plus. So we have Zn, 2 plus, phosphate. This ATE signifies a polyatomic ion. So we go to our chart and look where the phosphate is, and from our chart it is PO4, and that is a 3 minus. You can say -3 or 3 minus, that doesn't matter. All right, now we're going to cross our charges to the outside of the parentheses. Do not touch anything in the parentheses. So the 2 comes down, the 3 comes down. Check for lowest whole number ratio. 3 to 2 is lowest whole number ratio, so now we rewrite it. Zn3 parentheses PO4 parentheses 2. That is our formula for zinc phosphate. Okay, let's do another one. Let's do hydrogen sulfide. All right, so hydrogen, when it is the first element, so here it is acting as our cation. So hydrogen gets a +1. Sulfide, that IDE, this means that this is sulfur as a monatomic ion. If it was polyatomic, it would be sulfite or sulfate, but sulfide is just the sulfur as an ion. So we put in S, we check our periodic table, and we see that sulfide forms a 2- charge. And now we cross our charges. 2 to 1 is lowest whole number ratio. So H2S is the formula of hydrogen sulfide. And we've drawn Lewis structures for that molecule. So most of the compounds we're doing today are ionic, but actually H2S is covalent. So hydrogen, a lot of exceptions to rules. Okay, so what should we do next? Oh, I want to do two kind of side by side. Okay, so next we're going to do sodium hydroxide. And we're also going to do calcium hydroxide. All right, so we're just going to follow the steps. So sodium is in group 1, it forms +1 ions, so Na plus is the formula. Hydroxide, this is not hydride, it's hydroxide. On our chart, we have 2 polyatomic ions that end in IDE, the rest end in ITE or ATE for the negative ions. So if we look on our chart for hydroxide, it is OH with a -1 charge. Hydroxides are bases for acid and base chemistry. If you have a hydroxide, it is a base. So this is easy enough. It's just 1 and 1. We rewrite it as NaOH. And you might say, well, what about the parentheses? Well, I could put them, but when our subscript is a 1, you usually don't include the parentheses. So this means we have 1 sodium ion and 1 hydroxide ion. If you wrote it with OH and you kept the parentheses, that would be okay with me, but when you see this written anywhere, you will see it just like this, NaOH without parentheses. All right, let's go over and look at calcium hydroxide. So calcium is Ca, and it's in group 2. It's a 2+ ion. And hydroxide, we already looked that up. That's OH with the -1. Cross the charges. And then 1 to 2 is the lowest whole number ratio, so rewrite it as Ca. I have to include the parentheses now. OH2. This 2 means I have 2 of these groups that are inside the parentheses. I must have the parentheses. If I only have 1, don't need it. More than 1, I absolutely need it. And this is why. Okay, so if we write it as CaOH2, that's proper. If you write it as CaOH2, that isn't. When we write it like this is showing that we have 1 calcium, 2 oxygens, and 2 hydrogens, which is what we do have. We have 2 oxygens and 2 hydrogens. If we write it this way, it shows that we have 1 calcium, 1 oxygen, and 2 hydrogens. This is incorrect. We do not have that. This is what we have. So that is the proper way to write it. Include the parentheses if the number outside of the parentheses is anything other than a 1. All right, let's just do a few more examples. Let's do iron. Roman numeral 3 per chlor 8. Okay, so iron is Fe. Roman numeral 3 means that this particular ion is a 3+ ion. Our chart tells us ion can be +2 or +3. Here, it's 3. Perchlorate, we look on our polyatomic ion chart, and we see that we have ClO4 with a -1 charge. Cross the charges to the outside of the parentheses. Keep everything inside, just like it is. 1 to 3 is lowest whole number ratio, so we write our final answer as Fe parentheses ClO4, parentheses 3. We must keep those parentheses because our subscript is a 3. Okay, let's do another one, maybe our last one. We'll get ammonium thiosulfate. Okay, so now we have 2 polyatomic ions. That doesn't matter, we'll just follow the steps. So ammonium from our chart is NH4 with a +1 charge. Thiosulfate, we check our chart, and that is S2O3 with a 2-. Cross the charges. 2 to 1 is the lowest whole number ratio. We only check the numbers outside of the parentheses, so we're fine. Rewrite it. The NH4 must have parentheses because that is a 2. The thiosulfate does not need parentheses because there's only 1 of them. So this is our final formula. Okay, maybe I'll just do one more. If we have, say, barium oxide, all right, barium in group 2 has a 2+ charge. Oxide is oxygen as an ion. That is a 2- ion from our chart. If we cross these, we get 2 and 2. Well, 2 to 2, the lowest whole number ratio, both can be divided by 2. Lowest whole number ratio is 1 to 1. So now we write our final answer, and it's just BaO. We don't have to write those ones. That is barium oxide. All right, that's it.